pen.
All right, we had skipped around a little bit. And we had figured out that on number 3, it is continuous at x equals 3 because as x approached 3 from the left and from the right, I got 3, and h of 3 was also 3. So that actually was just a continuous function. Now we look at the second and the third one. Are we good? Okay. Second and the third one, they both have 5s in them. So we need to determine if it's going to be continuous or jump discontinuity or point discontinuity at 5. So we say as x approaches 5 from the left, h of x approaches, which equation would I use? The x, yeah, the second one, the green one. Yeah, the x squared minus 2x. So that's 5 squared minus 2 times 5. And that's 25 minus 10, so that's 15. Now we go the other way. As x approaches 5 from the right, h of x approaches, now which equation?
The absolute.
Yeah, the bottom one, the last one, absolute value 1. The absolute value of 5 minus 3, and then plus 2. What's that?
4.
That is 4. So they're not equal. It really doesn't matter, but I'm still going to find out what is h of 5. Do we have h of 5? Was that a yep or nope? To the absolute value one. Why? Do you know it's that one?
Because it's less than or equal.
Yes, it's got the line under it. It's greater than or equal to. So h of 5 is also 4. But since those two don't meet up, what kind of discontinuity is it? Jump. Yeah, because they're not going to touch. So, let's see. Since both pieces approach different y values, then h of x has jump discontinuity at x equals 5. Again, if I have time, I'll go back and do 1 and 2, but 1 and 2 are done the same way as 3. But I definitely want to get to this one. This is a fantastic free response kind of question. For what values of a and b will the function below have a point discontinuities at x equals negative 3 and x equals 2? So, we say as x approaches, we'll do negative 3 first from the left. Then f of x approaches 2 times x, which is negative 3, plus 3.
We don't do the comma.
You mean like right here?
Yeah.
Yeah. Well, I put then instead of the comma. Same thing. I gotcha. Sorry. I didn't do it exactly the same. But yeah, it gives us negative 3. As x approaches negative 3 from the right, then f of x, now it's the second equation. So it's a times x, which is negative 3, plus 3b. So that gives us negative 3a. Did I do that right? Negative 3a plus 3b. Okay. So for right now, I don't know what A is, and I don't know what B is, but that's what I'm trying to find. So now let's go to the other one that is asking us about, which is x equals 2. So as x approaches 2 from the left, comma, or then, f of x from the left would be that top one, approaches a times 2 plus 3b. That's just 2a plus 3b. And then as x approaches 2 from the right, f of x approaches, now I'm going to plug in 2 but into the bottom equation. So it's 1/2 times 2 squared plus 3 times 2 minus 1. 4 is 1/2, that's 2. Plus 6 minus 1, that's 7. So I'm reading through this. That should say not have point discontinuities. Because to find for that it would be a point discontinuities, there's like infinitely many answers. That's why I've been looking at it going, well, so let's have to with not. Sorry. Okay, so looking at this top part, if they're not going to be point discontinuities, then this should be equal to this. Because if it's not a discontinuity, those two should meet up. They should equal each other. And oh, wait a minute. I see what it's doing here. I don't like the way it did that, but okay. It is technically a point discontinuity because none of them are equal to. And none of these have the line under them. So it'll still be a point discontinuity. It just won't be continuous. My bad. So I just set those pink things equal to each other. So negative 3 equals negative 3a plus 3b. Can I solve that? No. I have one equation and I have two unknowns. I have a and b. I don't know either one of them. So that's why we had the second one.